So hello, everyone. Welcome another week to the amazing Kotlin Academy that we have here in a virtual environment. Today is my turn. I will be your teacher and I will be teaching you a very interesting and very interesting lesson that it will be about coroutines. We are going to talk about coroutines, about parallel execution, asynchronous execution of our instructions, and how all of these things works in Kotlin. I'm gonna share my screen first. I will do this. Okay. Okay, you can see my screen, right? Perfect.
Yes.
Yes.
Let me open also this thing. Okay, I'm ready. So, as I said, today we are going to learn about coroutines, how we can use them in Kotlin, what they are good for usages. We will do a lot of exercises, small pieces of code that you can see by yourself how they work and what are their advantages against when we are comparing them with the normal flow of sequential execution of our code. We are going to talk about the scopes of the coroutines. What is it? And basically, we are going to focus on builders, how we can create our coroutines. We have decided to divide the coroutines topic in 3 parts. So today is going to be the first part, and we are going to talk about these things. Next week, we'll have more coroutines with a little bit more advanced topic. And then the following week, we'll have another topic with coroutines and flow. So all these 3 parts will be like about coroutines, how we can use them and how we can take profit of them. So as usual, I left here some useful links to our Slack channel, to our GitHub, to the Kotlin manual, and also one interesting one about a link to the coroutines, directly to their GitHub. So if you are interested to see how they are working or how they are implementing some of the functions, suspending functions, and all of this stuff about coroutines that we are going to talk about. So here you have the link. Okay, and now we can start with a little bit of theory, as usual. As I mentioned before, we have different ways of executing our code within our app. Okay, so the basic one is that we have the sequential execution. This kind of execution is the one that we have been following in the previous weeks. That we have one line of code, another line of code, another. So everything is executed from the top to bottom. Or if you have some functions, so once reaches the function, it goes into the function, executes the code sequentially, exits, and continues with the execution. This is the traditional way of executing our code. But then we have more interesting ways of executing our code. It will be using parallelization or parallel execution by using different threads. And some of you may ask, okay, so Juanvi, what's a thread? Well, basically, you can think like a thread, like a different timeline. So you have the timeline of your app, and then you have a parallel timeline where you can run something independently from the first or from the main timeline. These are threads. So parallel execution, what it does is in one thread, we have some tasks being executed. In another thread, we have more tasks being executed, and they are independent. And finally, we have a third type of executing, that is the concurrent execution. And here, as we can see in the pictures, we can define this kind of execution as parallel execution plus they are like cooperating, okay? So the result of the task from one thread can be used as input to another task of another thread. So this is like you have 2 lines, one is working, when it finishes, returns the value to the first one, that it does their job, and then it can call another thread. It can open as many threads as possible to reach the final result. So with this bit of theory, let's go into our topic. Coroutines. Very simple. If I'm not opening this thing. Okay. What are coroutines? Here I'm explaining it in a nice way. Coroutines can be divided into parts: code and routines. Code from cooperation, and routines that are functions that we can define within our code. Okay. Everything, everybody's okay? Understandable? Any questions? Okay, I see a lot of okays. Perfect. So let's continue. Once we have defined what are the coroutines, let's go into another topic, that is the coroutine scopes. What is the scope of a coroutine? We can think of a scope as a box, okay? A box where we can put our coroutines, and they are running inside of this box. So all of the coroutines that we create into this box, they are following the same life cycle, okay? So as we can see here in the description, every coroutine should run within a scope. We will see later that if we don't define a scope, Kotlin has some global or default scopes by default. The scope is used in order to track the life cycle of the coroutine. Also, the way to bind the coroutine to an app-specific life cycle. As I said, you can think a scope as a box where you are running your things inside. What are the main advantages of the scopes? Well, we can keep track of the coroutines that are running. And the thing is that we can cancel the coroutines if they're no longer necessary. So why keep them there if they're doing nothing or they're using too much CPU, whatever, we can cancel them. And another important thing is that if something happens within the coroutine, we can notify the errors, and we can react to that. We can cancel it, we can restart it, we can do whatever we want. Okay? Was it understandable? Give me a hands up. If anyone has a question, please ask me. Okay, I see no questions, nothing. So let's continue. Our third topic here, where we have coroutines, the scopes, and finally we have the coroutine builders. Coroutine builders, we are going to use them, as its name suggests, to build coroutines. We have different ways of building the coroutines. One is using the runBlocking function. I'm going to define them very fast because we will see them later in detail how they work. So runBlocking runs a new coroutine, blocks the current thread until it completes. And you can set a name just to identify when debugging. Then we have another way of another builder, that is the launch builder. This is an extension function of the coroutine scope or the global scope. And what it does is also launches a new coroutine. But the difference with the previous one is that this one doesn't block the current thread. As you can see, runBlocking blocks the current thread. And the good thing of this builder is that it also returns a reference to the coroutine job. So you can assign this builder to a variable, and it will have the reference to a job. And this job, as you can see here in this image, has a life cycle. So you can react to that life cycle. You can cancel it, you can check their state, their status, whatever. Then we have the suspend functions. Suspend functions, let's say that it's not a builder per se, but it's like a modifier that we can add to our functions to say, hey, this function could be suspended and it can be used inside of a coroutine. So the definition is that you can suspend the execution of the current task and let another task execute, parallel execution, as we were talking before. The main thing is that it can be called within a coroutine. That's the main purpose. And there are two functions that are very useful inside of a suspended function. One is the delay, that we will see it later. That can pause the currently executing task for a specific time in milliseconds. Something similar to the some of you who are coming from Java environment, thread.sleep and the milliseconds. So it's something similar, but better. And then we have the yield function that what it does, basically puts the current thread, the current task on the back of the execution queue in that thread. So if there are two functions that are running in one thread, the task or the function that calls the yield will go to the back. So the first one will have the opportunity to execute. We'll see an example later and you will understand it better. And finally, we have the latest, the last builder, that is async and await. Basically, async, again, is an extension function of the coroutine scope as launch. And the good thing of async is that if we want to execute a task asynchronously and get the result, we have to use this builder. As I explained before, launch returns a reference to the job, but async can return a result, a value that we want to return to use for another thing. So this is the builder, and to fetch or to get the value, we'll have to call await. We will see it also later. So let's go for it. First task, as usual, open IntelliJ IDEA, select create new project. Very important, choose Gradle, Kotlin, JVM. Let's go for it. I have here my IntelliJ, create new project. We choose Gradle here on the left menu and inside Kotlin JVM. Anyone having issues? Do you all see this menu here? Okay, perfect. See a couple of responses. So once we chose Gradle Kotlin JVM, as usual, click next. Let's choose a name for our project. In this case, could be lesson 06. And let's click on finish. Everybody's okay. Everybody's here with this file open. You have to see this build.gradle file open in your IntelliJ. We are not moving anywhere unless you say yes.
Wait. Almost there.
Okay, I see that Jiri is downloading. What are you downloading? Okay, perfect. Let's give it 1 minute. So for the rest, if you manage to see this file, you can just go to the next step in the task, step number 5. Copy this line. and add it here. Easy peasy, just copy paste. Once you do this, you will see this small icon that is showing up here to me. It's like an elephant with this thing up and the refresh button. You can click it. It will download this dependency and it will be ready. Any issues? Anyone? Gisri is still downloading? Okay. Okay, let's continue. So if you see this icon here, as I said, or somewhere else in your IDE, just click on it. It will do some stuff, and it will finally show the build success. Once we have this, we can continue to the next step. As usual, let's create a new Kotlin file in the source folder with the name main. So source main Kotlin, new Kotlin file. Okay, I repeat, just in case somebody is lost. Source main Kotlin, right click, new Kotlin file class, and we name it main. And we have here our fancy file. Next step, copy paste. This function main with the two prints, we will put it here. And just to test that it works, we can run it and see if it prints start and end. Is anyone lost? Anyone has help and needs help? Are we all here with the function main copied and printing start and end? Okay, I see some responses. Perfect. Perfect. Let's continue. Next step in our task. Well, we have checked already that it works. So the first task, let's play with sequential execution. We know this. We know how it works. So create two functions called task1 and task2. Task1 will go from 1 to 200 with a delay of 10 milliseconds between iterations. Task2 will go from 1 to 100 with a delay of 10 milliseconds between iterations. Each task will print a message when finished and run both tasks in main between start and end. So the first, let's create our two tasks. I'm going to create them here at the beginning. From task 1, yes, okay. And task 2. We have our two tasks, okay? They are doing nothing. So task 1 will go from 1 to 200 with a delay of 10 milliseconds between iterations. 4. 1 to how much? 200. And delay of 10 milliseconds. Sleep. Everybody's following? I just created a for loop from 1 to 200, and inside there's a sleep of 10 milliseconds. And for task 2, I just copy pasted, just changing the 200 for 100. Each task will print a message when finished. Okay. Once it finishes, let's print ln task 1 finished. And I'm going to do the same for task 2. You see that it's easy. It doesn't have any complication, just a for loop and then a print. The only thing new that you can face is the thread sleep. For those of you who didn't program or know about Java. So with this sleep, what we are doing is delaying the iteration, the iteration for the for loop. And the last thing, run both tasks in main between start and end. Between start and end, task 1 and task 2. We can run it. Is everyone here? Everyone following? Any issues? I see. Okay. Fabrizio and Gustav, I see that you selected no issues, I hope. Okay, perfect. So, as you can see, this is the sequential execution that I explained before. So what we are doing when we are running our main function is we are printing, we are going to the first instruction, print start. Here we can see it in the output. Then we go to task 1. Task 1 is executing these instructions. First, the thread sleep for 10 milliseconds each iteration. So it should be around 2 seconds that it should take to run this for loop. And when it finishes, it prints this. And for task 2 is the same. But instead of taking 2 seconds to do the for loop, it's taking around 1. I'm not going to say 1 exactly because probably it's not. And the same, print is finished. And at the end, we go to this. This is the normal sequential execution. Okay, so let's go. Let's go to the coroutines. Let's play with launch. If you remember, launch was one of the first, maybe the second coroutine builder that we had in the description. So the first step, wrap each call to the task function. Wrap each call to the task function. Yeah, with launch. Okay. We do this. We are wrapping our task with launch. What happens? Why this thing is in red? And of course, if we try to run it, doesn't work. Can anyone guess what's going on here? No? Okay, so I'm going to tell you what's going on here. The basic thing is that, as I explained in the beginning, we need a scope to run our coroutines. So we don't have any scope here. So how do we create our coroutine within a scope? So basically, as I was writing here, no, I didn't write it here. Okay, so launch is an extension function of the coroutine scope, and we can just call it from global scope, not this, global scope. When you type global scope, make sure that you are choosing Kotlin x.coroutines, because you will have like 3 or 2 or 3 as I have. One is the Java X thingy that it doesn't work for us. So is the second one, the one that it makes reference to Kotlin Coroutines. With this, calling global scope.launch, we are making sure that our coroutine is started in the global and default scope of coroutines in our app. What can we do with the second task? So the same, global scope.launch. We have it ready. We run it. And what's going on here? As you can see, we have the print, the 2 tasks running on a different coroutine. And in the output, we see only start and end. What's going on? Can anyone tell me? Okay, sequence. Exactly. Peter, you're right. The main thread finishes soon. So we are parallelizing, as we explained at the beginning, we're parallelizing the execution of our code. So these two coroutines are in a parallel timeline, different from the main thread. So the function main is using the main thread, and the coroutines are in a separate universe, let's say. What can we do to make sure that this is working as expected? Okay, one simple thing. Let's use sleep, and let's make it run for 3 seconds, okay? So we are printing start, we are launching 2 coroutines, we are printing end, and we are waiting 3 seconds to see what happens. You see, start, end, task 2 finished, and task 1 finished. It works. So the next thing is next thing in here. Okay, yeah. So basically, as you can see, starting a new coroutine is very easy with launch. We just have to wrap the code that we want to run in a separate coroutine with global scope.launch, or with launch. We will see now an example, and make it run. In that way, we are parallelizing our execution. Easy peasy. Next task, playing with Dram Blocking. As I said here at the very beginning, Dram Blocking, it also runs a new coroutine, but it blocks the current thread until it completes, okay? Just to have this in mind, just have this situation in mind, because you can think that maybe using Dram Blocking, we can avoid adding this line, so we don't have to more or less calculate when all the coroutines will finish, and then finish our app or our application. So Dram Blocking. Let's wrap the call to the functions with Dram Blocking. This thing, Dram Blocking. In the middle of Dram Blocking, we are adding this guy. And let's comment out this thing. Is everybody here with me? with runBlocking and the 2 coroutines inside. Okay, let's run it. What happened here? Again, we are making sure that this is starting. We think that is running something and is printing end, but we don't see the results of the coroutines. We don't see the results of our tasks. Why do you think this could happen? Does anyone have any idea? No? Okay, so I'm gonna explain it. Very easy. We are again having the issue with the scopes. runBlocking is creating a new coroutine with its own scope. And here we are using launch with the global scope. So it's 2 different scopes. So we have one box with 1 coroutine and another box with 2 coroutines. These boxes cannot communicate, they cannot communicate between each other. So the only thing that we have to do is remove global scope. Now we have runBlocking that is creating a new coroutine with its own scope. And we're calling, or we are creating 2 new coroutines inside of the scope of runBlocking. So if we run it, we can see that it's working. We have start as usual, task 1, task 2, and end. We can see that we don't need anymore this thread.sleep for 3 seconds. So the main function, the main application, is finishing once the runBlocking is finishing. Okay, but another thing that you may have noticed is that this doesn't differ that much from the sequential execution, because we have print start, then we have the tasks 1 and 2 and end. So why? Let's say it in a bad way. Why the fuck do we need this runBlocking if it's exactly the same as a sequential execution? Well, basically because we are not using it properly. We could, if we want to parallelize the execution of our instructions, we can move this guy here. Also this one. Let's clean up. Oh shit, I closed this. So we have now everything inside of the runBlocking coroutine. So it will print start, end, and then the tasks, as we were expecting. But this still doesn't look that nice. How can we do it? Because, I mean, it doesn't look nice because we have declared here the main function, and inside of the main function, we have a runBlocking, and inside of the runBlocking, we have to declare all the things that we want to run. So it's not that nice. What can we do? Well, we can declare the whole main function as runBlocking, like this. That way we can get rid of this and this. We clean up a little bit. And I think you agree with me that it looks nicer. We have runBlocking inside our code, and if we run it, we should get the same execution, the same order: start, end, task 1 finished, task 2 finished. Any problems, questions? Everyone is here? Yes, Jesse, that's where we are going next. As Jesse mentioned, we have here 2 tasks. One is taking 2 seconds to complete, and the other one is taking 1 second. So why is task 1, the one for 2 seconds, finishing sooner than task 2? Easy peasy. As I said before, this thread sleep is not the best option that we can use when working with coroutines in Kotlin. There are better options. And here is where it comes the suspended functions. Let's remember what was the suspended functions. Suspends the execution of the current task and let another task execute. Okay, we can just stop the execution of something and let another task do their shit. It has to be called from within a coroutine, and we have delay and yield. I explained before that delay is similar to thread.sleep that we are using right now. So here's the kit of our thing. First task, let's add the modifier suspend to each task function. We go to our tasks, we add suspend, we add suspend. Is everyone here? I hope so. Yes. Okay. So what happens if we run this? Exactly the same. Nothing happened. And if you take a close look into our code, we see that the suspend modifier is a little bit like grace. So that means that it's not being used by this function at all. And that's why it's this Kotlin or this warning is showing that redundant suspend modifier. We could just remove it because it's not being used, but we want to use it. So what do we have to do to make use of this suspend function? The main thing, we can just replace thread.sleep with delay. And in task 2, we do the same. As you can see, now the suspend modifier changes color. Now it's a nice blue. And let's run and see what happens. You see that? Now we have the correct order. We have start, end, task 2 finished because it takes a shorter time. And then task 1. Perfect. This is what we wanted. And just by adding the suspend modifier to our suspending function and changing thread.sleep with delay. Okay. Another thing that I forgot to mention before when we were working with runBlocking, this runBlocking it's not very useful. For example, when we want to use it, or it's not recommended to use it in another suspending function. For example, if we are working on this function and we want to add a runBlocking, it's not a good thing. If you go into the documentation, just by holding in Mac command and clicking on the runBlocking, in Windows, I think it's with Control or Alt, something like this, you will see that it has like a nice documentation. And in the second line here, it is designed to bridge regular blocking code to libraries that are written in suspending style to be used in main functions and in tests. So it's not recommended to use it anywhere else, just in main functions, just to make sure that our program finishes when it has to, and when we are writing tests. Everyone has this working and with the correct order? Perfect. Okay, next one. We added the suspend modifier. We added the delay to our functions, and let's use yield. For yield, I'm going to do a little bit here. down. So something separate. Okay. As we said before, yield is used like to if you're in a queue, you call yield and you go back to the queue. It's like to give priority to another thread to run. So, for example, based on coroutines, let's launch a coroutine that will print, for example, hello. I will have a delay of 5 seconds. And then here, we are going to move this, for example. Okay, so what I'm doing is launching a new coroutine, printing hello, and delaying the execution. If we run this, start and hello, task 2, task 1. But you see that end was printed before hello. So what if we want to give priority to this coroutine? What do we have to do? Basically, we can just call yield. And by calling yield, what we are doing is this coroutine inside of Dram Blocking will lose priority, and this one will get more priority. Maybe we have to comment this because otherwise I think it won't work, because there will be like 3 coroutines working. Let's see if it works. You see now, we printed start, then we printed hello, because with yield, we gave priority to this one, but the delay is continued working. And finally, we printed it. And we can see the delay working because this last line didn't show up until the 5 seconds. Let's run it again. Start hello end, no end yet. And ta-da, here we are. Process finished with exit code 0. This is one of the cases where we can use yield. Very simple, just to give priority to another coroutine to run and do their things. Okay, I'm going to comment this and comment this once. Okay, and we have a little bit of time. Finally, let's play with async. Async, as I said before, we're going to use it when we want to get something from the execution of a coroutine. Let's see it in working. The first thing that we have to do is change the return type of task 1 to string and return the finishing message when the function finishes. Okay, task 1 will return a string, and it will return just this thing. Return this. Are we all here? Okay. And the last step, wrap task 1 with async. Task 1, we have it here with launch. Instead of launch, we're going to use async. What happens if we run it right now? Exactly the same. There's no difference between async and launch if we use it this way. But as I said, the important thing of async is to fetch or to get the value returned by this function. So we can do like this: assign this to this variable, to variable data or whatever you want to call it, and we can do println data dot await. As you can see, well, this await function, as I explained before in the documentation, what it's doing is waiting for the coroutine to finish. Once it finishes, it gets the value and returns it. You see that the return type of the await is string. If we had integer, for example, it would be int. Whatever type that you define, it will be here. We can do it like this. We run it. You see, we have start. Then we are running this coroutine in an asynchronous way. We are waiting for it here. That's why we have duplicated message here. And finally, we have this task. We have end and the result of task one, of task two. This async is very useful, for example, when we are doing some API or network calls, when we want to retrieve some information from database, when we need a result to launch another coroutine. It's very useful for whatever. This is the kind of execution that we were explaining here at the beginning. That is the concurrent execution. We execute one task in one thread, we fetch the value, and we use it in another place. That way we can concatenate all our tasks that are running in different threads. They are running independent from each other and in a very easy and readable way, because you can see here that this asynchronous way of working or way of coding, it's readable. You know every moment what is happening. I'm printing start. I'm running this task in a sync way, waiting for it to get the result. Then I will print it. This coroutine will be also launched. It will finish whenever. And finally, I will print this. Any questions, comments? Because we finished. Anyone had any issue with this? Any concerns? Okay, so that's it from me.